Hello and welcome to this Oracle CloudWorld presentation. In this session, I, Orlando Gentil, Oracle University instructor, will give you a brief overview of the OCI Storage Services. OCI offers four categories of storage services. Local NVMe, that offers locally attached NVMe-based SSDs. Block volumes, that let you dynamically provision and manage block storage volumes. File storage, that provides an enterprise-grade network file system. And object storage, a highly durable object storage. Let's start with the local NVMe storage. Dense I/O shapes and bare metal instances have the option to use local storage. It consists of NVMe solid-state drives that are directly attached to the host. The common use cases for this type of storage are large databases, big data workloads, and applications that require high local performance. The shape of the instance is what will define the total amount of local disk space, varying from 1 to 8 disks, that give you a total space from 6.8 terabytes to a little over 54 terabytes. The IOPS starts at 200,000 and can go all the way to 3 million IOPS, depending on how you configure the disks. Data durability is a user's responsibility. Still talking about block devices, let's move to block storage. The block storage service lets you dynamically provision and manage block storage volumes. Differently from the local NVMe storage, they are accessed through a secure and high-speed network. If you need to make an analogy, the block storage service works like a SAN, storage area network, where you will create the volumes. Volumes can be block volumes or boot volumes. The distinction between them is that boot volumes are used to boot an instance, while the block volumes are used just for data. Let's look at some of the block volume features. Block volumes are elastic, meaning that you can set size according to your need. When you create a block volume, you allocate anywhere from 1 gigabyte all the way up to 32 terabytes per volume in 1 gigabyte increments. The volume comes with a default performance level per gigabyte, meaning that the bigger the disk, the higher its performance. The cost of the volume is defined by the space that you allocate for the volume and the performance level that you set. I will get back to the performance tier later. Same way as the NVMe local attached storage, NVMe solid-state drives are used in the block volumes infrastructure, ensuring an outstanding performance. It runs on a high-performance network, allowing sub-millisecond latencies. Each instance can connect up to 32 volumes. Once connected, the volume appears to the OS as a regular block device, and from that point on, you can use the traditional block device tools to partition and create file systems. A volume can be attached to multiple instances, allowing sharing its content. Block volumes are encrypted at rest, ensuring confidentiality when the data is not in use, and despite running on a protected network, it's also encrypted in transit. To ensure durability, the infrastructure keeps several replicas across the availability domain, and it's done automatically, requiring no intervention. Those are the basic features of object storage. Next, I will cover individually other equally important features in a bit more depth. In the last slide, we mentioned that block volumes are elastic. You define the size of the volume at the creation according to your system needs. But what if those requirements change? Being truly elastic, block volumes allow resizing and you can extend its size. Resize can be done online or offline. The online process means that you will expand the volume size without detaching the volume from the instance or stopping its use. Offline, on the other hand, It's how the same operations are performed while the disk is detached from the instance. Resizing works only to increase the size of the volume. When I mentioned about the elastic capacity of the block volumes, I mentioned that the volume will have a performance level associated with it. This is true, but OCI gives you the ability to increase the performance beyond the default performance level. And each block volume can have that performance level set individually and dynamically when you change its tier. The tiers are Basic. It will give you the lowest cost, as cheap as block storage, and it's indicated if you have large sequential files being used. Balanced. That is the default level for new and existing block and boot volumes, and it provides a good balance between performance and cost savings for most workloads. Higher performance is the intermediate performance if you need higher IOPS, but not as much as offered in the next tier. Ultra high performance offers the highest performance level, going from 90 IOPS per gigabyte to 225 IOPS per gigabyte, offering the best possible performance. The tier of a volume can be changed without interruption, either using the console or using the CLI or the API. Along with the ability to change the tiers, the block volume service also has a feature called Auto-Tune Performance. If a block volume is detached from one instance and this feature is turned on for that volume, the volume performance will be changed to the basic level, avoiding unnecessary spending. In the previous slides, we talked about resizing and performance tiers. This slide here is to illustrate how simple it is to manage those aspects in an existing block volume using the console. To change the size, you just need to enter the new value, it will be processed, and the new size is effective. To change the performance tier, just slide the control or enter the numeric value. To enable auto-tune, just change the option to on. In all cases, after saving the changes, they will be processed, and shortly after, they will become effective. OCI block volumes provides the capability to create complete point-in-time snapshot copies of your block volumes. You can make a backup of a volume when it's attached to an instance or while it's detached. Those backups can be incremental or full backups. The backup is encrypted and is stored in OCI object storage. They can be restored as a new volume to any availability domain in the same region. This can be done either immediately after a backup or later if you choose. This capability provides you with a spare copy of a volume and gives you the ability to successfully complete disaster recovery within the same region. Backups can be automated using backup policies. There are predefined backup policies, and it also supports user-defined policies if you have different retention requirements. User-defined policies can also be used to automatically copy block volumes backups from one region to another. When a block volume or a boot volume backup is created, the source volumes tags are automatically included with the backup. When it comes to block volume replication, OCI offers two options. Cloning the volume, that enables you to make a copy of an existing block volume without needing to go through the backup and restore process. It's a disk-to-disk zip copy of the source volume, and it works within the same AD. When cloning a volume, you can choose a larger size for the destination volume, but don't forget to extend the file system later. The second option is the inter-region or inter-ADs replication. The replication feature is complementary to the backup feature. It's not a replacement. Backups give you a point-in-time snapshot of volumes that enable you to return to a previous version of a volume or a volume group. Replicas give you the current version of the data. Leaving block volume behind, Let's advance and talk about object storage. Object storage is an internet-scale, high-performance storage platform that offers reliable and cost-efficient data durability. The object storage service can store an unlimited amount of unstructured data of any content type. If something can be saved as an object, you can store it here. Instead of having access to a block device or a file system, the service gives you direct access to the objects. So, where is object storage used mostly? What are the typical use cases? One case is a content repository, highly available and durable content repository for images, videos, or any kind of files. You can also use it for unstructured and semi-structured data. For example, large data sets from pharmaceutical trials data, genome data, and Internet of Things. Also, application logs data for analysis, debug, and troubleshooting. Some OCI services send their logs to object storage, and from there, they can be consumed by other clients. Big data, Spark, Hadoop support. With HDFS connector, it provides connectivity to various big data analytic engines like Apache Spark and MapReduce. And very commonly, it's also used for archive and backup. The use of storage for preserving data for longer period of times. Most enterprise solutions allow you to use object storage as a backup destination. How the objects are stored in the object storage service. Object storage has a top-level container called namespace. It will hold all your buckets and objects inside it. It's your slice of the object storage service, and it's global, but it can be created. It's created at the regional level. This allows you to have buckets with the same name on different regions. I just realized that I mentioned buckets, but I did not explain what a bucket is. A bucket is a logical container for storing objects. The objects are stored in a flat hierarchy, and you can simulate a directory structure to make it easier to organize your objects. At last, we reach the object level. The object is a file or unstructured data, and it can be as big as 10 terabytes. Objects are treated as a single entity. You can edit or append to an object, but you can replace the whole object. Along with the object, its metadata is also stored. In the metadata, you have OCI metadata, but you can also add custom metadata. Object storage offers 3 tiers. Standard tier or hot storage for fast, immediate, and frequent access. Object storage always serves the most recent copy of the data when retrieved. Data retrieval is instantaneous, and standard buckets can't be downgraded to archive storage. It also offers infrequent access storage tier, or cool storage. Cool storage is ideal for data that you access infrequently, but must be available immediately when needed. Storage costs are lower than the standard tier, but you are charged per gigabyte data retrieval fee. There's a minimum retention requirement for 30 days if you are using this tier. Use cases include backups of on-premises data, storage data that was replicated or copied from another region. The third tier is the archive storage or cold storage. It stores seldom and rarely accessed data, but that must be retained and preserved for long periods of time. You have a minimum retention requirement for archive storage of 90 days. Objects need to be restored before you can download them. An archive bucket can't be upgraded to standard storage. And the time for the first byte after the archive is restored is 1 hour. Buckets can be either standard or archive, and you can change from one to another. But on standard buckets, you can change the tier of specific objects. It needs to be done manually, but if you can do that for the whole bucket, you can take advantage of a feature called auto-tiering. This feature will change the tier from standard to infrequent access if the objects have not been accessed in the last 30 days. If the object is requested, it will be changed back to the standard tier, and there's no penalty if it's before the 31 days retention. It's a smart way to optimize your costs. Another feature that is very interesting is the object lifecycle policies. If you need to transition data from one tier to another, you can take advantage of it. Using time-based rules, the objects will have their tiers changed to different cost tiers. You could, for example, move objects from standard to archive and automatically deleting after 180 days. A quick example on how you could use that. It's a smart way to make the service save money for you. Object storage also is possible to manage object versioning. Once it's enabled, it will automatically control the object versions for you. It provides data protection against accidental or malicious object update, overwrite, or deletion. As security is a paramount on OCI, on object storage, data is encrypted at rest and in transit, and this cannot be disabled. For very strict security requirements, you can choose to encrypt using your own keys. We talked about block devices, object storage, and we arrive at the last category of storage on OCI, the file storage service. With the file storage service, you can create scalable, distributed, enterprise-grade network file systems. They can be accessed across different subnets and VCNs, or even through VPN or Fast Connect connections. It's a high-performance, fully managed shared storage. Let's take a look at the common use cases for file storage service. A lift and shift of enterprise applications. Use it to migrate existing Oracle applications that need NFS storage, such as Oracle E-Business Suite and PeopleSoft. You can also use for general purpose file system. It can access to unlimited pool of file systems to manage growth of structured and unstructured data. Big data and analytics. You can use it to run analytic workloads and use shared file systems to store the persistent data. You can use the file storage systems to scale out applications. As you don't need to provision upfront, the file system adjusts its size as needed, avoiding bottlenecks in your application. And very common is microservices and Docker. It will deliver stateful persistence for containers, easily scalable as your container-based environments grow. Because it offers shared file system for compute instances and supports NFS 3, you might be thinking how that would be different from a Linux running an NFS server. It's quite more powerful. It's a fully managed services that ensures data durability through a 5-way data replicated storage through several fault domains. It automatically adjusts its size and performance, avoiding bottlenecks. And it offers 10,000 snapshots for data protections per file system. And on top of that, as everything is secure, data is encrypted at rest and in transit. OCI has a solid portfolio of storage services, and for every need that you have, there is a solution that will meet the requirement. Doing a quick recap, there are local NVMe storage and block volumes for block devices, file storage for shared file system, and object and archive storages for unstructured data. But And along with those services, OCI has offline and online data migration options. What would be the point of having all those options and no data to bring over? For scenarios where there is no or low bandwidth, you can use the offline migration. Through the data transfer service, you will ship the disks with the data to Oracle and will be loaded to your object storage bucket. If available on your region, you can even, and if you have a petascale data set, you can borrow at no cost the data transfer appliance from Oracle. In both cases, there are several steps to encrypt the data and ensure its security while they are in between your on-premises to OCI. For scenarios where bandwidth is not a concern, you can take advantage of the storage gateway. It's a free appliance that handles the transfer of data from your on-premises to OCI, storing it on buckets on object storage. This concludes our presentation, and thank you for your interest in OCI Storage Services.